Hello, my name is Emilie Roberts, a developer advocate working on Chrome OS and Android apps. Today, I would like to talk about how to make sure different input methods work for your apps across all Android form factors: phones, foldables, tablets, Chromebooks, Chrome boxes with external displays, Chrome bases with built-in monitors, and even Android TVs. For all of these devices, input is a crucial part of every user's app experience. Many Android devices have non-touch input built in, like Chromebook keyboards, and others offer them as standard options, like this keyboard and stylus that came free with my new foldable last month. Before we get focused on the technical details about how to support input devices, I would like to zoom out for a moment and underline the motivation behind this. Namely, you want your users to be able to interact with your app in the easiest, most intuitive way possible. If you buy a new device that comes with a keyboard, but your favorite app does not support standard key presses, that experience will be frustrating. This talk is entitled Input for All. The all here is really about the users, all users. I invite you to spend some time thinking about folks that might be interacting with your app and not using a phone's touchscreen. This includes things like a keyboard and stylus, but it also means users with accessibility needs. How do you make your app delightful to use for the greatest number of users? For each kind of input device, I would think about app functionality in two big buckets: standard and enhanced. Standard use cases include things like selection, text input, long press, and right click. This is the kind of functionality users just expect. Luckily, the technical implementation to handle these cases is straightforward and in some cases, automatic. To provide more unique and enhanced support for your app requires a bit more thought. These cases are not always just nice to have, but can really be required. For example, a mobile game that does not support game controllers could be perceived badly. Likewise, a text editor that doesn't support standard copy and paste shortcuts is not going to be successful with keyboard users. Where I think apps can really stand out is when they think beyond the basics and add unique and enabling functionality to their apps. For example, eDJing added support for keyboard DJing and trackpad scratching. They also provide MIDI DJ controller support to allow users to turn their phones or Chromebooks instantly into a DJ station. Cubases just released a Chrome OS optimized version of their Android app. It takes advantage of large screens as well as the ease of hooking up MIDI controllers to Chromebooks to make this top-notch digital audio workstation powerful and useful. Drawing apps are likely to be interested in making Bluetooth and USB drawing tablets work well, as well as leveraging Chrome OS's low-latency Stylus API to their drawing and painting apps. I don't think I can say it too often. Your users want unique, delightful, intuitive experiences in your apps, and it's up to you to provide them. Keyboards come built into many Chromebooks or are a daily part of the user experience for detachables, tablets, foldables, and TVs. The good news is that unless you are building your own on-screen keyboard or writing your own text input views from scratch, most basic keyboard input should work automatically. One exception to this rule is the Enter key. In a standard edit text view, the Enter key will create a new line. If your app has a chat functionality, a feedback form, a newsletter sign up, or anything where text is sent, the default new line behavior is not what you want. Supporting the expected send functionality is easy. Here's the code that looks for the Enter key being pressed. Override onKeyUp and look for key code enter. Be sure to return true if your app has handled the key event and pass the event up to super if not. If your app does media playback, include media key support as well. To do this, replace key code enter in the previous code with the media key codes you want to support, as shown here for Media Next and Media Previous. Don't forget to include space for playing and pausing with the spacebar. For games, you'd want to include the arrow keys and WASD support as well. This is just as easy. Find the correct key code in the Android documentation and watch for those keys. Note, generally with keyboard support, you want to look for onKeyUp. This way, you don't have to worry about the repeated on-key down events that will be sent if a key is held down. However, if you want to make sure you squeeze out every millisecond of response, you can watch for on-key down and handle repeated keys yourself. Check out chromeos.dev for more information. What about beyond the basics for keyboard? The main thing to think about here is control-based shortcuts. Obvious ones like copy and paste or undo and redo apply to many apps. Some apps go farther and put advanced capability at the user's fingertips, like how eDJing made it possible to scratch with the trackpad just by holding down the control key. Think about what your app could do with excellent keyboard support. Here's some code showing Ctrl-Z for undo. It is similar to the on-key up and on-key down code from before, but dispatch key shortcut event is used to indicate a meta key combination. Note, this will be triggered if Alt, Control, or Shift is pressed. If you only wanted to respond to a specific meta key combination, use the flags meta alt on or methods like is shift pressed or is control pressed. Here, I'm doing the undo action only when Ctrl-Z is pressed and the redo action only if Ctrl-Shift-Z is used. Alt is ignored. Like with the keyboard, most mouse and trackpad input should work without any extra code. It's still worth testing out all of your app's functionality with a mouse to see if there are any gaps. One of the most common oversights is right clicks. A common paradigm with touch is to look for long presses on the screen to perform context-based actions. However, long clicking with the mouse is not intuitive. To support right clicks, you have a couple of options. Here's the code for adding a context menu. First, register your view or views for a context menu. This will automatically handle both long presses and right clicks. Then, override onCreateContextMenu and inflate the correct menu layout. The same menu can be used for multiple views. And finally, set up onContextItemSelected to indicate what action to take when a specific menu item is selected. For other right-click behavior beyond context menus, you can set an onContextClickListener for your views. Just use it to call the same method you are already using for long presses. When a user is using a mouse or trackpad, they expect the UI to respond in a certain way. Seeing visual feedback when a mouse cursor is hovering over a view that can be clicked, maybe the pointer icon changes or some other visual indication happens, feels intuitive. Here's some code that looks for when the pointer is hovering over a view. Set an onHover listener to the view. Look for the hover enter event and then take some action. Here, I am changing the pointer icon to a hand and coloring the background blue. Don't forget to reset the icon and background color when hover exit occurs. The Android APIs also provide for advanced pointer handling and make it possible to add gestures, pinch and zoom support, and more. We don't have time to investigate all that today, but take a look at developer.android.com to get started. Another common mouse and trackpad enhancement that can be critical for some games and add functionality to some apps is pointer capture. This allows your app to capture the mouse cursor so that it does not appear on the screen. Your app can then receive relative pointer events without the cursor running into the edge of the screen. A good example of this are first-person point-of-view games like Minecraft Education Edition. To enable pointer capture, you can call request pointer capture and release it again with release pointer capture. To actually use the received pointer data, add a captured pointer listener to your code and use the relative change in pointer position to do something cool. And that's it. If you have added good pointer support to your app, Stylus should just work as expected for most use cases. There are a couple of enhancements that you should be aware of. Some devices have support for Stylus tilt and pressure. This can add some really nice control and functionality to your painting or drawing app. To see this in action, check out an app like Concepts on a supported Chromebook or Android device. Visit the documentation for access pressure and access tilt on developer.android.com for implementation details. Speaking of Concepts, they are one of a number of drawing apps that have implemented low-latency stylus support on Chrome OS. This library allows you to get the lowest latency display response and also offers configurable stroke prediction that can give you a pen-on-paper-like feel. Check out the low-latency library and demo app on GitHub. We'd love your feedback, so let us know what you think. If you are optimizing your applications for more advanced stylus support, you will be pleased to know that we've recently partnered with Microsoft to bring host machine stylus support to the Android emulator. This will let you test precise tilt and pressure control through the Android emulator on supported host machines.
Hello from sunny Seattle. My name is Guy Marine, and I'm part of the Microsoft Surface Duo Developer Experience team. Today, I would like to share with you some recent updates we've contributed to the Android community, which enables advanced input development and testing, such as the multi-touch and stylus support. This is an ongoing collaboration with Google, and we have made a few public contributions to the emulator program. Let's see those in action. A question we often get from developers is, how can I test my app using a pen when I'm running on an emulator? What you see here is the Microsoft Duo 2 emulator running on a Surface Studio, with two apps running side by side. A sample app on the right pane and Microsoft OneNote on the left pane. The sample lets you test pen pressure sensitivity, pen orientation, the eraser tip, and other pen buttons. On the left pane, we have the Microsoft OneNote app. Using the emulator, I can draw on the OneNote canvas and take notes or erase. We're also excited to announce that on touch-enabled PCs, the Android emulator now supports multiple touchpoints, which lets you test gestures and interactions with your app that require more than one finger, such as pinch, zoom, and other touch interactions. Let's see these in action on another emulator, the built-in Android Studio foldable emulator, which is running Google Maps. Here, just with using two fingers, I can zoom in and out of the map. But these emulator updates go beyond just two fingers, and they can support all the way up to 10 touch points if your hardware supports that. All the changes you saw here are not specific to the Surface Duo emulator and can work with other foldable emulators as well. At Microsoft, we've been using these emulator updates in the development and optimization of our own applications. For example, when we test pen interactions on multiple form factors, such as the Surface Duo, large screen, and other foldables. Thank you, and back to you, Emily.
If you have a game, you need to have gamepad support. Adding it is as easy as adding basic keyboard support. Look for the corresponding key codes and decide if you want to act on key up or on key down. One handy thing is that the key codes for game controller directional pads and keyboard arrow keys are the same. Just look for the key code D-pad events and your app will handle both. Gamepad buttons have their own key codes as well, so you can look for those, like I'm doing here for the X button. When it comes to specialized hardware, support will be specific to the device and your use case. MIDI support is especially interesting for music and creativity tools. It allows for a wide, expressive range of input signals, from pressure-sensitive piano keyboards to devices with many different input triggers like sliders and knobs, pads, and more. There are some handy open source samples in the Android Media Samples library that can help you get started with MIDI. Check out the MIDI Synth project, and in particular, the Synth Engine module in that project. Note, from Android 29 on, you can also use the NDK MIDI API. Let's recap the main ideas here. Large screen Android devices are here and growing in popularity. Good input support on Android has always been important, but it is even more critical for foldables, tablets, and Chrome OS. Lastly, spend some time thinking about your app's input handling and how you could increase engagement and unlock new functionality and app experiences. With that, I'd like to thank you for investing in making really awesome Android apps and, of course, adding incredible input handling. Enjoy the Android Dev Summit and be sure to check out our other talks for large screens.